Every 5 years, a document is published in Beijing that moves more concrete, steel, copper, and capital than any other planning document on Earth. It does not make headlines the way an election does. It does not trend on social media. Most people in the West have never read a single page of it. But the decisions written inside it determine which industries will dominate the next decade of the global economy, which technologies will achieve mass production scale, which infrastructure corridors will reshape trade routes that have existed for centuries, and which countries will find themselves either integrated into or left out of the most consequential economic machine ever assembled. China's 14th five-year plan ran from 2021 to 2025. The 15th, covering 2026 to 2030, is now in effect. It contains 28 designated mega-projects, each one representing a national priority investment of a scale that most countries cannot match in their entire annual infrastructure budget. By the end of this video, you'll know exactly what those projects are and why they matter more than almost anything else happening in the world right now.
To understand why China's 5-year plans produce results that no other country's planning documents do, you have to understand what kind of machine is executing them. China's government controls the major state-owned banks that finance infrastructure. It controls the state-owned enterprises that build it. It controls the land acquisition process through a system where the state owns all land and can allocate it for development faster than any democratic permitting process allows. And it controls the educational pipeline that produces the engineers, metallurgists, chemists, and logistics specialists who staff the projects. When China designates something a national priority mega-project, it is not making a policy recommendation. It is issuing a construction order to an integrated industrial, financial, educational system that has spent 70 years being optimized for exactly this kind of coordinated execution. The question for the rest of the world is not whether these projects will get built. They will. The question is what the world looks like when they are finished. The first cluster of mega-projects in the 2026 to 2030 plan addresses the foundation of everything else: energy.
China currently operates the largest installed base of renewable energy in the world. More solar panels, more wind turbines, more hydroelectric capacity than any other nation. And yet its electricity demand is growing faster than its generation capacity can keep up, driven by the electrification of transportation, the expansion of data centers to support its artificial intelligence industry, and the continued industrialization of its interior provinces. The plan designates the construction of a new generation of ultra-high voltage direct current transmission lines, UHVDC corridors, that will carry electricity generated by massive solar and wind farms in the deserts of Xinjiang, Gansu, and Inner Mongolia to the industrial and population centers of the eastern seaboard, distances of 2,000 to 4,000 kilometers. These are not ordinary power lines. A single UHVDC corridor can transmit 12 gigawatts of power, the equivalent output of 12 large nuclear power plants, across thousands of kilometers, with transmission losses of less than 5%. China has already built more UHVDC corridors than the rest of the world combined, and the new plan adds at least 8 more to the network, creating a national electricity superhighway that no other country has come close to matching.
But this is where things get interesting. The energy megaprojects do not stop at transmission. The plan designates the construction of at least 6 new nuclear power reactor groups, clusters of 2 to 4 reactors built on shared sites to reduce per-unit construction costs, using China's domestically developed Hualong-1 pressurized water reactor design, which has already received safety approval in Europe and is being exported to Pakistan, Argentina, and the United Kingdom. Simultaneously, the plan includes China's most ambitious commitment yet to advanced nuclear technology: the construction of a commercial-scale thorium molten salt reactor demonstration plant in Gansu province. Thorium reactors use a fuel cycle that produces dramatically less long-lived radioactive waste than conventional uranium reactors, cannot undergo the kind of meltdown that destroyed Chernobyl and Fukushima because the fuel is already dissolved in a liquid salt that flows safely if containment is breached, and can consume some existing nuclear waste as fuel. China is the only country in the world currently building a thorium reactor at scale. If the demonstration plant succeeds, the implications for global energy are difficult to overstate. However, the next step changes everything.
The second cluster of megaprojects addresses semiconductor independence, the single most strategically sensitive technology gap that China identified after the United States imposed export controls on advanced chips and chip-making equipment beginning in 2019. The plan designates the construction of at least 5 new semiconductor fabrication clusters, not individual factories, but entire industrial ecosystems, each containing multiple fabs, chemical supply plants, equipment manufacturing facilities, and research institutes, clustered in dedicated zones in Shanghai, Shenzhen, Wuhan, Xi'an, and Chengdu. The total capital investment earmarked for semiconductor manufacturing in the 2026 to 2030 plan exceeds 1 trillion yuan, approximately $140 billion, making it the single largest government-directed investment in semiconductor manufacturing in history. The strategic objective is explicit: to achieve domestic production capability for logic chips at 7 nanometers and below without relying on equipment from ASML, the Dutch company whose extreme ultraviolet lithography machines are currently required for the most advanced chip manufacturing, and whose export to China has been restricted under international pressure from the United States.
Most people never realize what this chip independence effort requires in terms of industrial depth. Building a leading-edge semiconductor fab is not simply a matter of constructing a building and filling it with machines. The process gases used in chip fabrication, ultra-pure nitrogen, argon, hydrogen fluoride, chlorine compounds, must be manufactured to purities of 9 nines, meaning 99.9999999% pure, because a single molecule of the wrong substance in the wrong place can destroy an entire wafer. The photoresists, light-sensitive chemicals applied to wafers before each lithography step, are among the most complex organic chemistry products on Earth, requiring hundreds of synthesis steps and raw materials sourced from dozens of countries. The silicon wafers themselves must be grown as perfect single crystals, 300 millimeters in diameter, and then polished to a surface smoothness measured in atomic layers. China's plan designates government support for domestic development of all of these upstream supply chain elements simultaneously, because imposing export controls on any one of them from outside would be enough to halt production.
The depth of industrial self-sufficiency being targeted is extraordinary. Not just fabs, but the entire chemical, materials, and equipment ecosystem that makes fabs possible. At this point, one mega project stands out even within a plan full of extraordinary ambitions: the Artificial Intelligence Computing Infrastructure Program. China's plan designates the construction of a national AI computing network, a distributed system of data centers collectively providing more than 600 exaflops of AI training compute, connected by a dedicated fiber and optical network backbone that allows workloads to be distributed across facilities in different provinces as if they were a single machine. To put that in perspective, 600 exaflops is approximately 3 times the estimated total AI compute capacity that existed globally at the beginning of 2024. The individual data centers in this network, some of them the size of multiple city blocks, consuming hundreds of megawatts of power each, are being designed from the ground up for AI workloads, with liquid cooling systems that can handle heat densities 10 times higher than conventional data centers, power delivery infrastructure designed for the pulsed, high-current loads that AI accelerator chips generate, and network architectures optimized for the massive data movement that training large AI models requires. The semiconductor chips that will power these centers, since the most advanced NVIDIA accelerators are export-controlled, are being developed by Huawei, Cambricon, Biren, and a constellation of smaller domestic chip designers, with the plan explicitly designating procurement targets for domestically produced AI chips as a percentage of total government and state enterprise purchasing. Now for the most impressive cluster of all, the transportation megaprojects that will restructure the physical geography of Asia. China's high-speed rail network already covers more than 45,000 kilometers, more than the rest of the world combined. The 2026 to 2030 plan extends it by an additional 10,000 kilometers, with particular emphasis on routes connecting the interior provinces of Yunnan, Guizhou, Sichuan, and Xinjiang to the coastal economic centers, and on cross-border connections to Southeast Asia through the Laos-China Railway Corridor that opened in 2021 and is now being extended toward Thailand, Malaysia, and ultimately Singapore. But the rail expansion is only one element of the transportation cluster. The plan also designates the construction of 4 new deepwater port expansion projects at Tianjin, Qingdao, Guangzhou, and a new greenfield port facility on Hainan Island designed specifically to serve the South China Sea trade routes, and the deepening and widening of major inland waterway corridors on the Yangtze River system to allow larger vessels to penetrate further into the interior, connecting manufacturing centers in Chongqing and Wuhan to ocean shipping at costs that rail cannot match for bulk cargo. Here are the facts that reveal just how unprecedented this planning cycle truly is. The total fixed asset investment designated under the 2026 to 2030 5-year plan, combining central government, local government, and state enterprise capital, is estimated at between $20 and $25 trillion over the 5-year period. That is roughly equivalent to the entire annual GDP of the United States, spent on infrastructure and industrial development every year for 5 years. The plan designates the training and placement of at least 500,000 additional engineers in priority technology fields: artificial intelligence, semiconductor design, advanced materials, aerospace, over the plan period, a human capital investment that dwarfs the engineering graduation output of any other country. The Three Gorges Dam, once considered one of the largest single infrastructure projects in human history, would represent less than 1% of the total construction value designated in this single planning cycle. The UHVDC transmission corridors designated in the plan will, when completed, be capable of transmitting enough electricity to power the entire European Union's current consumption, and they are only the energy transmission component of a much larger infrastructure program. The global supply chain implications of these 28 megaprojects are already being felt in commodity markets, manufacturing capacity, and technology competition worldwide. The semiconductor cluster investments have driven a significant increase in global demand for specialized chemicals, silicon wafers, and precision manufacturing equipment, raising prices and extending lead times for buyers in Taiwan, South Korea, and the United States who compete for the same inputs. The renewable energy expansion has made China the world's dominant buyer of polysilicon, the raw material for solar panels, and of the rare earth elements, neodymium, dysprosium, praseodymium, used in the permanent magnets of wind turbines and electric motor drives. The AI computing infrastructure program has driven Chinese domestic demand for high-bandwidth memory chips to levels that are reshaping the strategic priorities of memory manufacturers in South Korea and Japan.
And the high-speed rail expansion is drawing every country along its route into a deepening logistics and economic relationship with China, creating infrastructure dependencies that geopolitical tensions alone may not be enough to reverse. The quality control and execution monitoring apparatus behind these projects is itself a mega project. China's National Development and Reform Commission, the NDRC, maintains a project tracking system that monitors physical progress, capital deployment, and milestone achievement for every designated megaproject in real time, with quarterly reporting requirements to the State Council and the ability to reallocate funding between projects if execution falls behind schedule. Projects that fail to meet milestones face leadership accountability consequences that are more severe than in most political systems. The social credit system for enterprises, which rates companies on contract fulfillment, environmental compliance, and financial integrity, creates additional pressure on contractors and suppliers to deliver on commitments. The result is an execution speed and fidelity that project management specialists in other countries study with a mixture of admiration and unease. From a planning document drafted by hundreds of economists, engineers,
and strategists in Beijing translated into budget allocations, land designations, enterprise mandates, and procurement targets, executed simultaneously by millions of workers, machines, and supply chains across a territory the size of a continent. These 28 megaprojects are not just construction programs. They are a statement about what kind of world China intends to inhabit in 2030. A world where its electricity is generated domestically from renewable and nuclear sources and transmitted without dependence on fossil fuel markets. A world where its most critical technology, the semiconductor, is manufactured without dependence on any foreign government's permission. A world where its industries are connected by infrastructure so capable and so extensive that the cost and speed of moving goods, energy, and data gives Chinese manufacturers a structural advantage that geographic competitors cannot easily replicate. The engineer in Chengdu whose high-speed rail journey to Shanghai now takes 3 hours instead of 18. The factory in Xinjiang powered by solar electricity transmitted from a desert array 500 kilometers away. The AI researcher in Shenzhen whose training run completes in hours instead of weeks because it can draw on compute capacity distributed across a national network. They are living in a world being deliberately constructed around them.
One 5-year plan at a time. Which of these 28 megaprojects do you think will have the biggest impact on the rest of the world? The semiconductor clusters, the AI computing network, the thorium reactor, or the high-speed rail expansion into Southeast Asia? Tell us in the comments. And if this video made you realize how much of the future is already being built right now, a like and a subscription helps us keep tracking the projects that most people won't notice until they've already changed everything.